OpenIPDM is a collection of toolboxes designed in MATLAB and with the main purpose of navigating visual inspection data and performing operations such as learning deterioration model parameters, or like doing some post training analysis, and most importantly navigate and visualize the results or the deterioration state estimates for elements, structural categories, bridges, or even network. So in order to access OpenIPDM, there are different ways, but we have to be in the OpenIPDM folder. We make sure that we are, and we select the file openipdm.ml app. So if we right click on this and we click run, we will see that in the command line we would have OpenIPDM, which also indicate that we could have wrote OpenIPDM in the command window, and it would do the same thing by opening the interface. So this is the main interface of OpenIPDM, and as we see, the interface right now is empty because we have to load the database. Now we can avoid getting through this step, and we're going to see in details how we can do so. So let's load the database. The database is composed of several .csv files. These .csv files are going to be based on a demo database. So we have the structures database. We go ahead and load this file. So we go on demo data, and we go on structures database. And if you're working with the default database, the default columns or the mandatory columns will be pre-selected. So there are not going to be any hassle about selecting the columns. However, if you have like a customized database or custom database, then like the selection will be different for these columns. But these are the main mandatory columns. So we keep the same selection and we click OK. We go back to the loading panel and we go for the inspections database. We click on load and elements inspections. And again, we have the same thing about the pre-selected columns. We click OK. And we go to the following file, which is the interventions database. So realize interventions. Again, same thing with the columns. And for the budget database, so this is really a simplistic budget database, and the purpose of this database is that if there's an inspection report on an element that has not been reported in the realized interventions, we might examine also the budget database to determine if there's an intervention happened during a change in the condition of an element. So that's why the budget database is loaded here, and as you see, the columns in the budget database are really include the structure ID and the starting year of the spending and the ending year of the spending. So these are the main components of this demo budget database. So we move on to the next file, and we go to the inspectors database, responsible inspectors. So we have pre-selected columns for the inspector ID and the inspection ID. And we move on to elements details. This is the last file. And again, we have pre-selection. We click OK for the default selection. Now for the details about the information in each column and so on, there are other videos that discuss these, or there's like the PDF manual document that would be also available. So after loading all the files, we click OK, and then we would receive another loading menu for the model parameters. So this menu would load the parameters file for all the structural elements, for all the deterioration models and so on. So we go to parameters, and we load the file default model parameters. So after loading this, we click OK. And then the toolbox is ready. So this is the main interface. We see that a list of bridges has been already loaded in the structures panel. And we see that we have a category panel, element panel, and similarly on the right side, we have multiple tabs for element, category, structure, and network. So we go to the first tab, and let's select one of these structures. So we select structure 5. You see there are multiple categories in this structure. Some of these categories are visual inspections, so there are visual inspections associated with them. Some of them are not. So in the case, or if we have, if we haven't trained the deterioration model, the software would say there is no, this element either have no inspection data or has no model or model parameters associated with it. So if we navigate to a structural category that has actually visual inspection data, you go to this category, category 4, we see the list of elements. So this category in this particular structure or bridge, 005, category 4, we have a list of elements here, and we see that there is an intervention that took place in the year of 2015. So we see the effect of this intervention on the condition of this element, as well as on the deterioration speed of this element. Now, if we want to change the forecast, we can extend this forecast by year. So we can extend this forecast duration. It's taking a little bit of time. So we go back to the same element. So that's with the extended period of forecast, and we can do so up to 20 years after the last inspection point. So this is for the elements. Now, if we want to extract this figure, or if we want to save this figure, we can click on extract and save, and we can see that what the toolbox will do is that it will export this figure in the same format, so you can see it as an independent figure in MATLAB. And also it will convert this figure into a .tex file. So there is like which is compatible to be compiled in a .tex compiler. So this is for the extract and save and the forecast period. You see also here that we have outliers, missing data, or missing interventions autocorrect. So the purpose of this is that in the case of one of these observations shows a jump while there is no intervention report, the software would look into other databases to find clues for if an intervention took place, and will apply it in case if it happened, and if there's no clue about that an intervention took place, then like either it will run the model as is, or if the jump in the element condition, this jump in the element condition is too large, then the toolbox might remove the outlier and it will replace it with an asterisk. So we'll try to find an example for such a scenario. But this is really the role of autocorrect on, and this is by default on. So it's preferred to be this way. Now we see also there's a button for the intervention service life. So if we click on it, because we have an intervention here, if we click on it, we'll see that there's gonna be a new figure. There is a little bit of slowness in the interface due to processes running in the background. So we see the figure for the interventions and we see that we have a PDF here with the mean value or the expected value for this PDF is at year 2040. So this is really the probability of return. So probability of return to the state prior to the intervention, to this state, it's around the year 2040. So that's for element level analysis in general. If we go to category, we see the same figures as well. So we can see that we have, so if we want to, for example, to do the forecast on the same category, category 4 in this bridge, so it means that evaluate and merge the deterioration state estimate for all these elements. So to do so, we click on, so once we change the forecast bar, the toolbox will automatically respond by performing the forecast. So if I do this again, you see that the toolbox is automatically performing the forecast for the category, and it's distinguished from a different color from the element. So we see the color here. So this is really the condition deterioration estimate for all the elements in this category in this bridge, and similarly for the deterioration speed. Now here are the some of the other interventions codes. So for example, if we want to see the intervention CDF, we can select like what intervention code. So the intervention code here means a type or type of intervention. So intervention code 3000, according to the manual of inspections for the province of Quebec, the intervention code 3000 indicate that there's a major intervention, and the intervention 2000 or intervention code 2000 means that there's reparation or like some kind of mid-level interventions. In other words, the effective intervention code 2000 in general is lower than the effective intervention code 3000. That's like in general. So you see that we can actually get the CDF for these interventions either locally, which means only on this bridge, or globally, which means on the network. So if we try it, so here I run the software again. So and let's try to run it to see this intervention, whether it's 2000 or 3000. Let's keep it 3000 and run it. So now it's examining all the elements within this category, and this is the CDF for the intervention, which is the CDF for the return to the condition prior to the intervention. So in order to have further details, there's an already published work that would help in interpreting the curve about the intervention. But this in general, what its role here. And we see the same switch here for outliers and autocorrect for missing interventions. So, and also there's like an option to extract and save the figures as we see them here, as we saw earlier, or we can get the condition speed and speed report for a given year. So for a given year on this structural category, we can get the condition and speed report. It will export a .csv file. So we move on to the next tab, which is the structures tab. And in this tab, we see the same figure again. But this time, if we want to get the deterioration state estimate for the structure 5, so the entire structure, so it means that we're going to merge all the elements and then merge all the categories to get the deterioration estimate for the structure and for the principal elements. So we have two types of elements. They're going to be like principal elements that are associated with the carrying the vertical loads or any type of loads or passing the loads to other elements. So these are principal components such as like beams and slabs. There are secondary components such as the pavement elements and so on. So if we want to do an evaluation for all the principal elements in bridge number 5, we do the forecast for, let's say, 10 years, and we click Analyze. So we see that the software would first filter the group based on the principal elements. So these are the principal categories. And then like we see each one of these elements, and we see the graph for this structure is shown as follows for the condition and the speed. So these are the aggregation deterioration estimates for this particular structure, which is different from this category. So, and again, we can extract and save these figures as well. So if we move on to the last tab, which is like for the network. So if we want to evaluate all the principal elements for the entire network, we can do so. So let's go ahead and do like for 15 years principal elements, and for all the bridges that are currently active. So this like are one of the filtering criteria. And we can click on Analyze. So by clicking on Analyze, the toolbox would run on all these structures. So you see that in the background, the toolbox is running on all the elements, all the categories in the principal group for all the structures. And it will do the processing as we go through it. Now this, depending on how large is the data set and how many structural components in each bridge, the time for such an operation would be different in each time. So in this case, it's relatively fast because there are few structures and few structural elements in general, but in real context, this can really take a lot of time. So that's why there's a possibility to actually save these results and even load them later on to if like one seeks to do some comparisons. So this is like really the deterioration state for the entire network, for the condition and the speed for all the principal elements. Now we can also do the secondary elements, but like this is really for the demo. Now, these are the main visualization functions in this toolbox. Now there are like other menus. So for example, here we have under each one of these panels for the structure, category, and element, we have a sliding menu to filter out these structures. So for example, I can filter by municipality. And I see the menu here, it appeared at M1 or M2. So if I select M2, these are the structures that belong to municipality M2, and M1, these are the structures belong to M1. If I want to go back to all, I get back to all. And similarly for the elements category, so either I have a group or all the categories. So if I want for structure 1, select I want to filter the elements by group, principal, and go, and we would have the elements categories, principal elements categories for the structure 1.